today. My name is Karthik Thumla. I'm the technical marketing engineer from Cisco's enterprise networking business. In this particular session, I'm going to talk about Cisco SD Access for Zero Trust Workplace. So if you look at network practitioners, like the world of network practitioners has dramatically changed from the past 5 to 10 years. Like if you look at it, we typically worry about broadcast storms, switching loops, or spanning trees in general, right? But if you look at it right now, the world has completely changed with the proliferation of IoT devices, the digitization. The number of unmanaged devices are fivefold when you compare to managed devices. And these devices are vulnerable for ransomware and malware attacks where they can laterally move through privilege escalation. And not just that, right? The attack surface is much larger right now. And with the new industry trends, which we have mainly post-pandemic, if you look at it, we have smart buildings, we have automated warehouses. These all possess a unique security challenge for our workplace. And if you look at it, every other week, I hear one or the other ransomware attacks. And that seems to be the new norm recently, because we used to hear about malware previously, but now I'm hearing about ransomware every other week. So we need a solution which can provide which can eliminate unauthorized network access, which can go and actually prevent the lateral movements of threat, both internal and external threats, as well as effectively segment the endpoints like an IoT endpoints coming into the network. So this is all done through the Zero Trust Workplace thing, what we can enable through Cisco Software Defined Access. So Cisco Software Defined Access provides a more comprehensive workplace security using zero trust principles. So what is zero trust, right? So if you look at it, zero trust provides least privilege access to the endpoints or the devices which are connecting to the network. So when you look at software defined access, which is powered by the automated network fabric, both wired, wireless, so we tightly integrate Cisco DNA Center, which provides network orchestration through Cisco Identity Services Engine, and we provide complete endpoint visibility. So when I say complete endpoint visibility, I'm going to talk about that in detail in a couple of slides, but it provides more comprehensive visibility. And not just that, it will also provide a multi-level segmentation, both macro and micro level segmentation. And along with that, it will also provide a continuous monitoring of the endpoints which are connecting to the network. So if you look at it, it is all done through these pillars. So primarily, we do the enhanced visibility using Cisco AI Endpoint Analytics, and we provide segmentation using the virtual networks and scalable group tags. And along with that, we provide the continuous monitoring of the endpoints and their behavior using the trust analytics with AI spoofing detections and whatnot. And similarly, by continuously monitoring the devices, through Cisco DNA Center as well as through ICE, we provide secure network access for the endpoints which are connecting to the network. And we do that using posture assessment and some other techniques what we have in ICE. And finally, if any endpoints gets compromised in the network, we do rapid threat containment where we can go and quarantine that particular endpoint from the network. So with that, let me talk in detail about the Cisco AI Endpoint Analytics within Cisco DNA Center. So if you look at it, we do have some traditional mechanisms to profile the unknown devices, like an IoT device connecting to the network. So we do have network probes, which we know, which we classify using ICE, like DHCP class identifiers, radius, and whatnot. But through AI Endpoint Analytics, we take deep packet inspection, which is powered by the NBAR engine. And along with that, we also take the legacy network probes, which we gather from ICE, like SNMP, Radius, DHCP, HTTP, and whatnot. And also we provide some easy onboarding tools like endpoint registration tools, as well as we do have integration with the CMDB connectors like ServiceNow, where we can gather those attributes and we can share that with Cisco Identity Services Engine to create an authorization rules for onboarding these endpoints which are coming into the network, like mainly the IoT endpoints or the medical endpoints which are connecting to the network. And this is all powered through not just deep packet inspection, which I highlighted earlier, it is also done through AI and ML. Along with that, we do the crowdsourcing of those endpoints. So we do have like a device lake, which I'm going to cover in a bit. But net, all the endpoints, which are the unknown endpoints, will get profiled as like an IP cameras, the workstations, the iPads, the manufacturing equipment, or hot monitoring systems or whatnot. So this is all powered through Cisco AI endpoint analytics. So let's look deeper into what is deep packet inspection, right? So as I mentioned earlier, when you actually connect any device, like when you use any legacy classification, so we get the DHCP class identifier. So in this particular example, I'm taking a Globex Ultima CT scanner, which runs Windows 7 on it. So we take this and we got the DHCP class identifier. So the moment you see the DHCP class identifier, ICE profiles this particular system as a Windows workstation, right? So that is using the traditional profiling techniques. But through deep packet inspection, which is embedded within the network fabric, like on Catalyst 9000 within the SD access network, so we can do more application level visibility through NBAR and CBAR. So we can find what kind of manufacturer, what kind of model, and what kind of operating system and the endpoint type this particular device has. So this is a DICOM device, that is the model, and the manufacturer is Globex, as you can see, which we got from the deep packet inspection. So net, in Endpoint Analytics Engine, we provide a multi-factor authentication, multi-factor classification using the model type, the manufacturer, the operating system, and the endpoint type. And here, the endpoint type is the CT scanner. So that's how we power through the deep packet inspection. And you might argue like, hey, what if I don't have a 9K device? So we can also run a traffic telemetry appliance, which can do a regular span, remote span, or ER span in the network, and we can gather all the telemetry information from the endpoints which are connecting to the network, and we can able to provide the complete visibility of the IoT endpoints which are connecting. So that is on the deep packet inspection side. And apart from that, another differentiator we have on the endpoint visibility side is through the machine learning and the crowdsourcing. So we have a complete database we call device data lake, which is hosted in the cloud, where all the multi-cluster classification of the endpoint data which we gather using DPI, ICE, and ServiceNow integration with CMDB, we share that information into the device data lake. And now within that, if you still find any unknown devices, the beauty of ML is it can do the clustering of those different asset classes. So how does it do? It is based on the attributes it learns. So it learns the attributes, what it has, and based on that, it will group them or categorize them into different buckets. We call it as like clusters. And then ML also goes ahead and creates a rule for these unique endpoints which are coming into the network. So once you group them together, now you have an option as a network practitioner to go and write a policy saying that, hey, I know what kind of device are these. These are like Bosch coffee machines. So I can go and create a rule within the AI engine, which is part of endpoint analytics. And similarly, ML also suggests, if it also knows about these types of clusters, which are like Apple Watches. So it will also suggest a rule saying that, hey, these particular endpoints are Apple Watches. So now you have a full-blown labels which you have learned that saying these are the Bosch coffee machines and these are the Apple Watches. And this is the key differentiator which we have seen from any of the traditional classification system based on the context. So we provide much more context using the AI and ML and crowdsourcing along with deep packet inspection.
Could I ask a question?
Yeah, sure.
Is there like a single repository for all these device classifications? So the example you used where ICE misidentified a CT scanner as a Windows device and used DPI to update that. What happens with that identification? Do I update ICE with that, or does it sit somewhere else? I'm trying to understand where my identification and all my policies sit.
Yes, that's a very good question, Drew. So what would happen is the moment you see the CT scanner or as a workstation, that is the first set of attribute what ICE learns. But through endpoint analytics, which we integrate with Cisco Identity Service Engine via PX Grid, we share all the attributes information, what we learn, like the multi-factor classification, which I highlighted earlier. We share that is a DICOM device, this is a CT scanner, and all these attributes. So as a network administrator, you can go and create your authorization rules based on that within ICE, so that you can accurately profile these endpoints.
I guess my question was, though, does ICE then get an updated classification to say that
Yes.
wasn't a Windows device, that was a
Yes.
CT scanner? And
yes.
And okay, so I guess I'm trying to figure out what's the sort of chain of authority to say, ICE, you need to change this classification.
So within ICE, you have these profiler policies, which you have. So you go and you can identify those based on the attributes, right? So you can update your profiler feed information based on different assets. So whatever the attributes which you have learned, so you can automatically trigger the change of profiler policies using COA, which is change of authorization. So it will automatically go and update that particular device as a DICOM or a CT scanner.
Okay, thank you.
Did I miss something about what canned device profiles come with the product?
When you say what kind of devices come with the product, so ICE do have a complete feed of information which is readily available. So we constantly monitor that, and along with that, when we talk about the device data lake, where we do crowdsourcing, right, where we partner with all the customers, they can share all the different attributes which they learn for this manufacturing or IoT devices. So the AI and ML engine has this intelligence where it can learn all the new set of devices or the assets which are connecting to the network, so that we can provide the more enhanced visibility into the network.
So you're not kind of on your own having to identify everything. You're starting with a pretty good base, and then you're benefiting from what others do.
Exactly, because that is the whole idea of that crowdsourcing, where we gather all those intelligence from the rest of the customers who are deploying all this manufacturing equipment. And that's how we can scale too.
Hey, this is Gerard. I just had one quick question. So just to make sure I understand it. So those devices, you guys are constantly, they're being monitored, and then when they get registered on the network, they automatically pick that up and they start getting classified?
Yes, that is correct. So I'll
Okay.
show that. I'll show that in the demo as well, Gerard, if you go in details. Yeah.
Okay, cool. Thank you.
Yeah, no problem. So so with that, what we have seen is the enhanced visibility which we can do using AI endpoint analytics, right? So moving on, so now we know that these are the different asset classes, but we need to identify what are the traffic patterns of those devices. So we can gather that intelligence using traffic telemetries, using NetFlow data, or through security stealth watch analytics and whatnot. So we can model the behavior of the traffic patterns of IP cameras talking to the media servers or the log servers, or the streaming devices talking to the media servers. So we can gather all this intelligence using policy modeling. So what apparently we do is we observe and fine-tune this data for days and weeks, and then we ask the network administrator to go and create these policies based on these different traffic patterns. So the moment you deploy a policy, so you have seen that the cameras are talking to the log servers, the media servers are talking to the employees or the streaming devices. So now you go ahead and you push the policy through Cisco DNA Center, which gets provisioned onto your network fabric. So that is all done through the group-based policy analytics, which tightly integrates with the AI endpoint analytics. So we have seen how we can classify as well as we can identify the groups as well as the traffic patterns of the endpoints which are connecting to the network. And we take a step further by segmenting the network using the network fabric, which is done at scale using Cisco DNA Center with the macro and micro level segmentation. We call it as like a multi-level segmentation, where we can effectively segment your network using virtual networks as well as the scalable group tags. So that provides a two-level hierarchy of segmentation. So, and again, this is a common policy which you can write for both wired and wireless devices. And we can also provide a complete SD access fabric assurance capabilities to see the device health score, the 360-degree view of your endpoint, as well as the devices which are connecting to the network. And the network fabric enables the zero trust network at scale, where we can orchestrate and automate all these virtual networks as well as scalable group tags using Cisco DNA Center. So we have seen how we can effectively segment the network, as well as we have seen how we can go and we can create the policies, mainly the micro and macro level segmentation policies within the SD access fabric network. So what if the endpoint is vulnerable or the endpoint is behaving weirdly based on different traffic anomalies, right? So what we have taken a step further is we are actually monitoring the endpoint behavior by continuously monitoring the endpoint trust. So that is done through our AI spoofing detection, the spoofing behavior, where we look into the probe spoofing, the MAC spoofing of the device. And along with that, we also do, based on the profiler anomalies, what we gather from the Cisco Identity Services engine. And also we look into the authentication mechanisms, what these endpoints are running, and the posture metrics. If it is like a workstation, we can gather the posture data, and we can provide the trust-based score for these endpoints which are connecting to the network using continuous monitoring. So you can see I have a trust score based policy saying that if your trust score is between 1 to 3, I deny access, whereas it is like 7 to 10, I provide like a full access to the network. So this is all powered through AI spoofing behavior, as well as the continuous monitoring through trust analytics, which is part of the Cisco DNA Center as well. And we tightly integrate, along with that, we tightly integrate with Cisco Identity Services engine to do an adaptive control, like a rapid threat containment policy, which I can create if a specific endpoint is compromised. So I can go and I quarantine that particular endpoint from the network using an ANC policy, which we have seen previously, right? So we can still use the ANC policy. We can go and we can deny that particular endpoint from the network.
Just real quick, so is there any preset policies already in place, or are you going to create each one of them manually as you're going along?
For this trust-based policies, you can provide like what granular level of access you want to do. So we can create the trust score automatically, which I'll show in the demo as well. So the trust score for these endpoints will automatically gets created. So what level of access you want to give based on the trust score is something it's completely up to the network operator how we want to do it.
Awesome, thank you.
Yeah. And let's look into some of the spoofing techniques which are being used by the hackers, right? So most common, and we have seen this since many years, is the MAC spoofing, where they can take the MAC address of the specific asset class and they spoof that MAC address and they profile that particular device as a IP phone in this particular example, and they can get a privileged access to the network. And similarly, we also have probe spoofing behavior, where an attacker can take the attribute information like the asset class, the DHCP class identifier in this particular example of a Cisco IP phone, and he can gain a privileged network access to the network. And these kind of the traditional impersonation of unauthorized devices can be contained using the AI spoofing detection technique, what we have, which is through the trust analytics, which I highlighted earlier. So with that, let me show a series of demos covering all these things which I highlighted earlier, starting with the endpoint visibility. So within Cisco DNA Center, when you log in, so you have this AI analytics, which needs to be enabled. So it is enabled through the network settings. When you come into the settings and external services, you can see this. So you enable the AI endpoint analytics. And once you go into the policy section, that is where you see the AI analytics. So the moment you land into the preview page or the overview page, you can see the total number of endpoints which are connecting to the network. If you have any missing profiles, which can be highlighted, all that here. And along with that, you can see the endpoint random MAC information also seen down. And if you look into the right, you also have the trust score, which is available for these endpoints. So I'm going to talk about that detail when I cover the AI spoofing detection. But in net, if you look at it, we can provide the complete endpoint overview in this particular section. Now, if you hop on.
Sorry, quick question. When you're to enable AI analytics, is there any sort of base infrastructure requirements to be able to run that on your DNA Center infrastructure?
Yes, that's a very good question, Drew. Yes, we do need a certain version, which is DNA Center 2.12. And along with that, we need at least ICE 2.6, the patch 2 or higher.
I was thinking more on the hardware side.
From the hardware side, yeah, obviously, as I mentioned, if you're running a Catalyst 9000, then obviously we can provide more capabilities using DPI. But if you're running any legacy devices within the network, so we can leverage, as I mentioned, a traffic telemetry appliance, and we can provide the complete enhanced visibility into the network using traffic telemetry appliance.
Sorry, it's the infrastructure to run DNA Center.
So whatever the infrastructure you have to run the DNA Center, like you can use any third-party network device, or you can use Cisco devices like Catalyst 9000. And from the DNA Center perspective, yeah, obviously it's a 3-node cluster which you need to deploy within the shared services environment.
Okay, so there's no specific, processing memory requirements, whatever, for running AI on DNA Center on top of everything else.
Oh, no. Oh, if you're looking for that, now I got it. Okay, no specific. So it is all part of the licensing what we have. So as long as you have the DNA Advantage license, that should take care of it. No specific hardware requirements are needed for this.
Thank you.
So moving on, so you guys can see, I have shown you the overview section, and similarly, I have the endpoint inventory section where you can see the different asset classes. So I can click on the endpoint type, and I can see different kinds of endpoints. And one particular thing which I have on interest is the IP camera, which you can see, and it is an OS type of Linux, and the endpoint type is the camera. And similarly, I can also go in and I can look into the different kinds of profiles using our multi-factor classification. So when I talked about multi-factor classification, I highlighted that we use endpoint type, the hardware manufacturer, the hardware model, and the OS type. So you guys can see here, all those entities can be highlighted, and we can filter the endpoints using that. So now we can share all these attributes automatically by through the PXGrid integration to Cisco Identity Services Engine, which can accurately profile these endpoints. And we can write the authorization rules of this. So we have seen how we can go and we can create that multi-factor classification. So the next step is we need to see the behavior of the endpoints which are connecting to the network, right? So we need to identify the traffic patterns, we need to look into the net flow data and whatnot. So that is done through the streaming telemetry, what we have through Cisco DNA Center, where we can go and use Cisco DNA Center as a net flow connector. So as you guys can see, this is an option under the network telemetry settings. You can enable that. And then we can also pick what kind of analytics you want to use for identifying the traffic patterns within the network. So if you look at it, we have different data sources. One is, of course, the streaming telemetry using NetFlow. And also, if you are integrating with StealthWatch, we can do the StealthWatch security analytics integration, and we can also provide more advanced flow data using the StealthWatch security analytics. And obviously we integrate tightly with Cisco Identity Service Engine via PXGrid, so we can get all the profiler feed information as well. So these are the different.
Question there.
Yeah, sure.
Can we get client profile and NetFlow data and quite a bit of client information without integrating ICE?
No, without integrating with ICE, we can't get the profiler feed data. I'll show that in the next section. So because we do have based on ICE profile, so when we integrate with ICE, we get this profiler information through PXGrid.
Okay, so what if we're not looking for then profiling, we're just looking for that application visibility?
Yes, so if it is just an application visibility, yes, absolutely. Using NetFlow, you can able to identify the traffic patterns between the devices. That's all done through, yeah. So moving on, so you guys can see here, I have the traffic telemetry, which is being enabled on these two devices. These are my Catalyst 9000 series switches. So you can see if I go in, these are two 9300 switches where I have enabled telemetry data, then automatically all the flow monitoring information gets carried and shared with the network fabric. And now when we go into the policy under group-based access control, so that is where we actually see the analytics, the policy analytics. So this is the thing which we see for the traffic based on either scalable groups or ICE profiling field. Like earlier there was a question, can we use just the data from the streaming telemetry? Yes, you can just click on the scalable group tab. So when I click on the scalable group tags, I can see different traffic patterns based on the source and my destination scalable group. So here I have two scalable groups, which of my interest, mainly patients talking to the doctors or my critical medical systems talking to the doctors. So all this information and all this flow data will be collected by the group-based policy analytics engine. And similarly, if you have integrated with ICE, like I highlighted earlier, we can also see the different asset classes of the source of profiles, the Apple device, and how they are communicating with the source and the destinations. So all that flow data can be gathered here as well. And we can hover to one of these and you can see the behavior, like a critical medical systems are talking to the doctors, and similarly like an IP phone is talking to a doctor for communication and whatnot. So all these traffic patterns and flows can be identified using this group-based policy analytics. And it's pretty powerful to identify the traffic patterns and showcase the policies what are needed in your network.
I got a quick question.
Yeah, sure.
In regards to correlation for endpoint devices, are you guys matching V4 and V6 information? So like I think in 2.2, you guys had V6 support that was enabled for dual stack configurations. So the devices on the left, if it's an IP phone that has V4 and V6, if it's being exploited on V6, but using transport for V4, can you guys actually know that that's the same device, correlate that event set together? Or is that a separate thing that's going on and you're seeing one flow for V6 and one flow for V4?
So we should be able to see both the flows for V4 and V6. That shouldn't be any problem here. But the key here is, at least from the EA side and the GBPA side, at this point of time, we fully support the dual stack endpoints from the network fabric. So that shouldn't be any problem. So we support complete dual stack, so we should be able to see that.
Right. It's just more of, in terms of when you were talking earlier about, red, yellow, green in terms of capability of forwarding traffic, right?
Right.
If you're being exploited and your out of band control network is happening on V6, but the exploit's happening on V4, you'll shut down the V4 flow, but you won't shut down the V6 flow because that's the command control side. Or is the reverse happening? Can you actually detect and correlate those two pieces of information together to know that they're actually related? Because that's a big structural problem in a dual stack network, right? It's like you can have that sort of split. You can do, lateral sort of exploits on V6 on one side, on V4 on the other, right? Like, how does that work out? Are you guys looking at that problem space, or is that still something, roadmap to be determined?
That is still in the roadmap we are working, but at least from the scalable group tax perspective and the policies perspective, Ed, yes, we do have V6 support right now, right? So we can able to gather the behavior. Like if I have like a critical medical systems scalable group and I have a policy of V4 and V6, I can see the traffic pattern using both V4 and V6. At least that part we are there. But like the more advanced capabilities like you highlighted, yeah, definitely some of these things are in roadmap.
Cool, thanks.
Yeah. So moving on to the next demo, which I would like to highlight is what we have seen in the earlier demo is primarily on the visibility aspect of the endpoints, as well as using endpoint analytics and the policy analytics. So in this particular section, I want to highlight the provision through multi-level segmentation, what we can do using Cisco DNA Center. So what we have enabled with the latest DNA Center version is the SD-access provisioning workflows for your multi-level segmentation. So you guys can see I have a virtual networks, fabric sites, and transits and peer networks. So I can click on that and I can go to my virtual network screen. You can see this is my virtual networks overview page, and I can look into different segments which I have created. So this is my layer 3 virtual network. I can create that layer 3 virtual network based on like a different kind of building management system can be part of one layer 3 VN, and guest can be part of a complete layer 3, separate layer 3 VN, and we provide complete segregation of traffic using this layer 3 virtual networks. So this is all can be done through the workflows within DNA Center. That's a cool thing about it. And you can see the workflow is pretty straightforward. You can go, you can click on how many VNs you need. You can name it like an IoT in this particular example, and I can click on what location. I'm using SJC4 here, and I can click on like what kind of exit behavior you want for that particular virtual network. And also you can look into the summary before pushing that button. by clicking the deploy. So automatically that IoT virtual network gets created within your network fabric. So you can see this is an IoT VN with a layer 3 VN ID. And when you click on the details of that IoT VN, and you can see the details of like what is a route target and the route distinguisher and all. And also I can go ahead and create an IP address pool assignment for that particular IoT virtual network. So once I click on that IoT VN and add gateways, and here I can go ahead and I can create an IP address pool assignment for that particular IoT virtual network. So you can see I have used an IP pool of SJC IoT, and my VLAN is sensors device. So essentially I created a demo-sensors as a VLAN with a VLAN ID of 90. And here I have an option to pick not just the layer 2 VNID, but also I can also have the capability to add the scalable group tags. And again, it's not just for wired. As I mentioned, this is a common policy which we can enable through network fabric for both wired and wireless. So I can enable this even for the wireless infrastructure. So I select wireless and I go in there and I provision this particular layer 2 VN, which is essentially a gateway. And once I put it, automatically a layer 2 virtual network gets added within Cisco DNA Center. So you can see I have an IoT, which is demo-sensors VLAN, which is part of an IoT VN with a VN of 90, which is a VLAN ID of 90. So now that I have this particular VN, I can go into the group-based access control, which provides the micro-level segmentation capabilities using scalable group tags. So I go into the DNA center, I go into the group-based access control. So this is where you can see the policy matrix view, a complete view of what kind of policies you have in the network. So I go and create a policy between, in this particular example, specifically, I want to create a policy between my doctor scalable groups and the patient scalable groups, which contains the sensor devices. So I want to create a policy between doctors and sensors. So I go and I hover on that, and automatically I click on the cell, and it will enable you to add a policy contract. So here I add a policy contract saying that I want to permit a network access between my doctors and the heart monitoring sensor devices. So the moment you provision that, automatically that policy gets added within the Cisco DNA Center, and that gets provisioned via ICE to the network fabric. And that instantiates a policy onto the network fabric so that at that point of time, doctors can talk to the sensors devices. So net-net, we provide a multi-level segmentation using both macro as well as using micro.
And I would emphasize that the macro can be set up, at least the way I've been designing it, is to set it up to force traffic to go through a firewall, whereas the micro is enforced by the switches.
Yes, we can send that information to the firewall for more enhanced monitoring. And between the virtual networks like building management systems and my campus virtual network, I can just allow communication, or if I'm denying the communication, I can go through the firewall so that the firewall can monitor all the traffic. And if I'm denying or allowing, everything can be written within the firewall itself.
So I want to follow up on that as well, Karthik.
Mm-hmm.
I understand the TrustSec model is to leverage scalable group tags and SGACLs, and I totally get the benefit there. Where I struggle with SGACLs is that they're enforced on egress, which is fine for destinations that are in the SD access fabric, but once you leave the fabric and go into the data center that might not have granular EPGs defined, how do customers answer that issue?
Yeah, that's a very good question, Tim. So there are a couple of ways how we can address that. I'll tell you. So ACI being one thing, like you highlighted, using the tight integration between EPGs and SGTs, and we can create a correlation of SGTs and EPGs and whatnot. But as long as you have the network device, which is TrustSec capable hardware or SGT capable hardware, then we can able to go and we can create that segmentation policy right at the network device itself. But if the network device doesn't have a capability, what we can essentially do is we can do a midpoint filtering, right? So in the SD access fabric, we have an SD access border device. So we can go and we can create the NSXP session for these data center prefixes from ICE via SXP, and we can share that mappings onto the SD access border. So on the border, I can do the filtering of those traffic. So I can do a midpoint filtering. So because ICE have all this intelligence, and on ICE, I can create subnet to SGT mapping or IP to SGT mapping. So I can go and I can create more granular IP to SGT bindings in ICE, and I can do the policy filtering right at the SD access border. So you don't even need to go all the way down to the ACI fabric or all the way down to the data center. You can do midpoint filtering as well.
And by designing IP pools in a coordinated fashion so that your VNs summarize, you can make it play well with vendors that don't talk PX grid and security group tags.
Yes, Pete. So we have a couple of ways, right? Like you mentioned, yeah, if someone knows about PX grid, like some of our other vendors can talk to PX grid and they can get the context, so we can write the SGTs and whatnot, right? So we can create the policies. But if you don't have that capability, yeah, we do have a way, as I mentioned. So either you can do that policy filtering at the border or at the access level as well.
Yeah, two of the other firewall vendors have taken their Microsoft domain communicating server and extended that to do PX grid and pick up the groups as well. So that could be handy.
Yes, Pete. That's exactly the intent of our PX grid. We want to share all this contextual intelligence with our vendors, and we need to provide that more granular segmentation policies. So you can see I have an AA spoofing detection for the Mac spoofing. So I have two devices. Primarily, I have my I have my IP phone, which is connected to the Cat9K device, and this has a MAC ending with 9896, and an attacker, he tried to spoof the MAC address of an endpoint as he's coming to the network, and we can see how we can detect that using the AI spoofing detection technique. So the first step, we go into the AI spoofing detection settings within DNA Center. We enable AI spoofing detection, and then we select the different trust sources. So I can pick like change in profiler labels, AI spoofing detection, concurrent MAC address, and whatnot. So the moment I selected all this, then I can go into the behavior of these endpoints and see like what endpoint has the lowest trust score. So here, this particular IP phone is of my interest at the bottom, ending with 9A96. And you can see it has a trust score of 2. So now I go in there and I click on the endpoint and I can see the details. It says that it's a Cisco IP phone, and the asset class information, the OS type, everything is highlighted here. And the next step is I want to look into the trust score of the endpoint to see like why it has a less trust score, right? It has a trust score of 2. So I look into the AI spoofing detection, and it says it has a 1, and also it has the authentication method and concurrent MAC address. So I can click on each and individual details to understand what's happening there. So when I look on the AI spoofing detection, it says that it is talking to different anomalous applications. It is an IP phone. It has to supposed to talk to just the SIP server call manager. But if you look at it, it is talking to all kinds of applications. So that itself, the spoofing detection technique will identify this and lower the trust score of that particular endpoint. And similarly, it also has the concurrent MAC address detection technique, which I highlighted earlier. So we can see it was supposed to come through the gig 1/0/1, but it is also coming through some other edge device on a different interface. So we can also lower the trust score based on that. I mean, the AI engine will automatically lower the trust score. So at this point of time, I can go and I can do an ANC policy of that particular device where I can quarantine that particular endpoint from the network. So using the rapid threat containment technique, which I highlighted. So you go, you apply the rapid threat containment policy, you can see the ANC policy is now quarantined, and that particular network, that particular endpoint is being removed from the network fabric. So that is based on the AI spoofing detection. And similarly, I have other asset class, which is a workstation. You can see it has a trust score of 10. And we can also look into that to see like why it got a trust score of 10, right? So you can go into the details, we can look into the endpoint type, the multi-factor classification, and we can look into the posture assessment. You can see it is a posture compliant. So it is gathering that intelligence from ICE saying that this particular endpoint is a compliant endpoint. It has a thorough posture running, so we can give a trust score of 10. And it also has a .1x authentication, so it got a trust score of 8. So net-net, it is a more active endpoint in the network, and we can go and we can provide a full access to this particular endpoint based on continuous trust monitoring, what we have enabled through trust analytics. So with that, I would like to highlight Cisco SD Access is the only industry solution which can provide complete workplace security through zero trust by identifying and grouping the different asset class information and also observing the traffic patterns and traffic flows through endpoint visibility as well as the group-based policy analytics. And apart from that, it can also provide more granular segmentation policies using virtual networks and scalable group tags. And also it can continuously monitor the behavior of the endpoint using posture assessment and other vulnerability scanners, and it can evaluate the endpoint behavior to provide a trust score using the trust analytics. So it provides a turnkey security through SD Access network for your workplace using the zero trust principles.